Hi, they say you can't switch high voltage DC with regular contacts, and that's right. But if you have the right circuit, like this, you can switch with no problem. My heater control system keeps the panels at a constant voltage, and here's the panels, and this is the input voltage, and on the other side we have a capacitor bank for the heater control. Now what happens is when you open these up, this side is at power point voltage, your MPPT voltage that's on the back of the panels, and when it opens up, this side goes to the full open circuit voltage. Now if you look at the difference between those voltages, in a 60 volt arrangement like I have here, it's about 14 volts, and that's well within the ratings of any relay or switch. So this shows the transition, and it's going from 60 volts up to about 72 volts. And let me just show you that right here happening. So we got the switch, and we're going to open up the switch. There it goes to 72 volts. The capacitor bank is still at around 60 volts. And that transition is pretty clean. That takes about 68 microseconds to totally complete, and that's very good for, you know, a hand-operated manual contact. And you know, most of the arcing and everything else is done within 5 to 10 microseconds. But that's how it's done. I mean, this is a slick little system, and this allows you to use your heater thermostat that's right on a water heater. No need to do anything special. No need to buy expensive relays. You know, you just use this board and this little circuit. Like I say, here's the power point voltage. We're at about 60 volts. And when you open the switch, it goes up to the open circuit voltage. Capacitor bank is still at this, so you're only looking at a differential less than 30 volts. So you could get over 100 volts on solar panels and not have any problems with switches at all. When we do shut off the heater still draws about 2 watts, so it's doing a little bit of drain. As you can see, it's 2.4 watts. And that just keeps the capacitors up to full voltage almost. And so when you close the switch again, you're not getting any big zap or anything, because they're fairly charged already. It's a neat system, and it works. I've been using it at my camp, but that's how we go. 60 volts up to 72 volts, that's just 12 volts. That's not too hard to switch. And if you look at this waveform, there's no nasty glitches or anything. You know, it's just a fairly slow transition. And if you have an MPPT controller on this that has input caps, the transition is going to be even more gentle. Because if you put just a few microfarads of capacitance on the input, it would slow the time up that you wouldn't see any glitches at all. So thanks for watching. I think this is pretty interesting. Stay tuned for more ideas.